Okay, so this is a video about programming one of these things, octagonal star kit. Have a look at the chip on there. It's a bit small to read, but if we stick it under this microscope, I think you can see there that we've got an STC 8G 1K17 and underneath it tells you it's in a TSSOP20 package. So the 8G, well, the STC is the manufacturer, 8 is the type, G I think is the revision, 1K means it's got 1K of RAM, and the 17 means it's got 17K of flash memory. At least I think that's the case, but I may be wrong about that. But that's my understanding. So if we go and find the data sheet for this chip, we find that to program it we need a serial programmer, and all we need to connect up is VCC and ground, which are the power wires, and two other pins which are transmit and receive. Right, so the chip is very small and fiddly to solder to, even if you use some of these sort of hook wires. These are the best, they're more, can you see that? A lot smaller than crocodile clip wires. Of course you could solder some wires on. So we need ground and power. VCC is very easy because the whole metal shell of the battery case is VCC. I've removed the battery, so a hook, it's better to remove the batteries and power it off your interface while you're programming it. So we hook the power one onto there, the red one. Ground's more tricky. I found that the one pin of the buzzer is ground, and I've left it a little bit proud on this board. Can you see that? I haven't cut it off flush, so we can hook the black wire onto there. Now if you've already built yours and you have cut it off flush, you'll have to try and pick the ground up somewhere else. There's a few options. There's the back of the switch, I think maybe. There's the other side of the battery, but that's just the big pad on the board, which isn't easy to grab onto. Unfortunately, ground doesn't go up to the legs of the LEDs. The red wire had popped off. I'll hook that back on. So that's power and ground. So the transmit and receive wires are a bit more difficult, but they do go to some of the legs of the LEDs on the points of the star that are labelled 1 and 2. And we've actually got to connect to the third pin, well, I'm calling it the third pin, of legs 1 and 2. Now on this board, again, because I knew I was going to be doing this, I've left those pins a little bit long, so I could just hook the wire straight on. But you'll find that you can actually get them on around the legs of the LED on the other side, and it's in fact I don't know if the camera will focus here, but if you look closely you'll see that one of the pins has got a square cut out on the silk screen. That's the pin you've got to go to. So I'm going to do that off camera and I'll show you once they're hooked up. Okay, so there are all the wires hooked up. We've got the one black wire going to the leg of the buzzer, the ground leg of the buzzer. We've got the red wire from that pair going to the sort of main metal shell of the battery holder. It's just clipped off, or I'll put it back on. And then the other two, it would have been good if I'd got other colours, but I've only got red and black. I've put the black one onto the pin of that one, that's number 1, labelled on the silk screen. So number 1 point of the star, and what I'm calling the 3rd pin of the LED. That's one's going to number 2 of the star, and again the 3rd one. And it's the one with, you'll see, it's got like a square surround to the pad rather than a round one. So those are all the connections to the starboard. Okay, so now we're looking at the software we need to do this, and we use a utility called stcgal to check and program the chip, and that's actually a Python program. So what I'm going to do is load up a command shell. I'll just type in cmd. This is Windows 10, but it works much the same, Windows 11. Worth making a folder, so let's change directory to documents. You could do this first in Windows if you want with the interface, and then do it there, but I'm doing it from the command line. I'm going to make a directory, mkdir, call it stc, and we'll change into that. Just zoom in a bit, see if it's still in focus so you can see what I'm doing. Yeah. So what we've got to do is use a pip3. Oh, I'll just do Python first so you can see what version I'm on. So type Python and it should tell you what version I'm on. I'm on 3.13.1, which I think is the latest. If you haven't got Python on your machine, just go and install it. Make sure you tick the thing that says add it to the path. Get back out of Python by just typing exit. And then we want pip3 install and it's stcgal. Well, it says it's successful, so if it is, I'll just do a dir, see what's in this folder at the moment. Nothing yet, so I don't know where it's put stcgal, but if I type stcgal, we'll see if it runs. I couldn't open the serial port, so if we type in stcgal, I think it's -h for help. It tells you the parameters for it, and the ones we'll be interested in is the -p for the port, minus, that's a lowercase p, and then possibly minus uppercase p if we need it to tell us it's an STC8. But I'll just try it with a, I know from the Arduino IDE that my Arduino was on COM8, so if I type in STC -p COM8, let's see what it says. Oh, stcgal I should have typed, shouldn't I? stcgal. stcgal minus lowercase p COM8. And it's saying, waiting for MCU, please cycle power. Right, so on the star kit, the easiest place to get at the transmit and receive lines, so if you look at the point of the star that's labelled number 1, that's the one with a hole, presumably so you can hang it on a Christmas tree or something. If we turn it over on that number 1, you can see that one of the solder pads is square, and that's the one pin we want. So it's the square pin on the star point number 1, and if we rotate round to star point number 2, again we want the square pin. So we need to get a wire onto the square pin of star points 1 and 2. You can either solder to the leg of the chip, leg of the LED I should say, or maybe tack a wire on the other side. If you've got some of those small hook probes, you might be able to hook a wire on, but those are the two we're after. So I've tacked some wires onto those pins I mentioned. So on the star point labelled 1, I've put this white wire with orange stripes. I'm using these telephone cable with a solid core because it's easier to use with a breadboard, you'll see in a moment. So that's star point 1 square pin is white with an orange stripe. Star point 2 square pin white with a blue stripe, and I've put the mostly orange wire with a white stripe I've soldered to the battery holder metal shell, that's VCC, and to get ground I've gone on the back of the board on one of the pins to the buzzer, and it's the one that's nearest to R2, and I've used the blue wire with the white stripe for that one. Now I tried to do this with an Arduino Uno, the serial port on an Arduino Uno board. I couldn't get it to work, so I've fallen back to using this one here. So most USB to serial board should do. I've shoved that one into this breadboard. Come on, focus for me. And I've put the white with the blue wire, white wire with the blue stripe, going to the RxD pin of the programmer. The white wire with the orange stripe going to the TXD pin, and then I've extended the plus 5 volts and the ground wire from the programmer, the USB to serial interface, to the 0 volt track on the breadboard and the bread track at the other end. So the orange white wire that goes to the battery shell is in that red track, and that leaves the blue one, which I'm using to power the thing up. You'll see that as part of programming it you have to disconnect the power, and it's best to disconnect the earth, because if you disconnect the plus 5 volts the board still gets it sort of still draws power down the transmit and receive lines, doesn't reset properly. But if you disconnect the ground, that does reset it. So you'll see in a moment when I'm showing you the code, the programming process, it'll say disconnect power, or whatever it says, cycle power, and at that point I'll be taking this blue wire out and putting it back in again, and that just applies power to the target board. Okay, so let's have a look at, oh by the way, some of these programmers, depending on which one you use, have the transmit and receive pins labelled wrongly. You know, they transmit either means this is the pin that transmits, or it means this is the pin to connect to the transmit pin, depending on which board you're using. If it doesn't work, just swap them over. So try it. If it doesn't manage to connect, just swap the pins over, the two wires over. It won't do any harm if they're the wrong way around. Okay, so here we are looking at a command prompt, and we're going to use stcgal to flash a program to the chip. So the first thing is to do, just to make sure that you can talk to the thing, is to do stcgal, and you need minus lowercase p and the name of the COM port, which on this Windows computer is COM9, but it could be something different on your machine. And that's it. When you enter that, stcgal asks you to cycle the power. So I'm going to plug in the ground wire, the blue one in my case, and you can see it reads the chip, which proves that you can talk to it. Tells you a whole load of things about it, settings and so on. Up at the top you can see that it's an STC8G, so it's identified it properly. So the next thing to do is same command again. This is to erase the existing program in the flash. So it's the same thing again. You put a minus E, space minus E at the end to ask it to erase the flash. Again, it's saying waiting for MCU, cycle the power, which I'm going to do. Didn't work that time, we'll try again. Sometimes you get a bit of contact bounce when you're connecting and reconnecting the wires, and it stops it working. I think that's why it doesn't always work. So this time it's done it. It says erasing flash, done, disconnected. So the next thing now is to upload the new hex file to it. If I do a dir, you'll see I've got the source code in here, the .c file, which I'll discuss in a bit. But the one we're after is octagonal star.ihx. I think the extension stands for Intel hex format, and that's what the when we run the compiler, I'll show you a bit, that's the file it produces. So the command to upload that, it's the same thing again, stcgal. This time we don't need the minus E because we're not erasing, but we just put the name of the hex file at the end, which is octagonal star.ihx. So again it asks me to cycle the power, and when I reconnect the ground it detects it. It erases the flash again anyway, but we've already done that, and then you see you get a progress bar, and it's done it. So if I'm going to pan the camera around now. Well, no, I'll do that later. I'll show you. But I can tell you that the board has now got the new program in. It's flashing the LEDs. If I press number 1 on it, it will play the first of my tunes. Can you hear that? It's sort of Super Mario World, Super Mario Brothers Overground theme, is it called? Anyway, doesn't matter, we'll stop that. So now, how to compile it. So assuming you've got the C file already in the folder, which we have, I'll delete the IHX file so you can see that we're going to recreate it. star.ihx. So the compiler, it's sdcc, which is Small Device C Compiler. You look for it on the internet, you'll find it. There are download packages for Windows, Linux and Mac, I think, and you just run it. So this is the Windows one. You just download the appropriate file, run it, that's it. There's a thing to tick to say include sdcc on the path, which is a good idea because it saves you having to type the whole path in every time. So the command to compile, very simple, it's just sdcc and the name of the file you want to compile, which is, or files. Octagonal star.c. It can compile multiple files if you want to split your source code across them, and you can then link them together. You can use make and so on if you want to, but keep it simple, that's all you need. sdcc octagonal star.c. And you can see it doesn't say anything unless it finds any errors, but it will now have produced a whole load of files. And the one we're after, which we used before, is octagonal star.ihx. But you can see it's also produced a .asm file, which is the assembler. The C compiler produces assembler, which is then assembled to produce the actual IHX file. And the other files are all things like maps of where the variables are in memory and so on. Interesting to study them if you want to know how the compiler works and how you might optimize your code, your original C source code, to make it smaller or faster or whatever. But you don't have to look at any of those, of course. So that's how you get the IHX file if you want to modify the source code. I'll just show you the source code while we're here. So if I fire up Notepad++, which is the editor I tend to use when editing these little source files in Windows. So you can see up at the top there's some comments about how to compile it and how to upload it, which I've just shown you. And then if you scroll down you'll see the first bit of the tunes. So if you want to add a new tune, you've got to turn it into numbers. So there's a number for each note. It's explained in the source listing. So there's a number for each of the notes. So you turn your tune into notes, and then there's also a number for the length, you know, whether it's a quaver, a crotchet or whatever, for each one. And one of the note numbers is for a rest, 0 I think. So I think 0 is a rest and all the other numbers are notes. And then the lengths, I think it's 3 for a, if by memory, I forget. Anyway, it's commented in the source code, and you can also do a tempo shift. So if you've got a very slow tune or a very fast one, you can alter what the note lengths mean. So those are all the note lengths and the tunes. So you'll see how to add your own if you want to. And then if we scroll down a bit, there's all the support routines that flash the LEDs and things. The bit that actually does the LED patterns is down here. So you see it says, is that on camera, switch pattern? We've got case 0, case 1 and case 2. If you study those, you'll be able to figure out how to write your own LED patterns as well. So I'll pan the camera around now and show you the board actually running this new code that we've uploaded. You get a sort of strobing effect with this camera, which makes it look as though the LEDs are blinking on and off, but to the naked eye they're nice and smooth and more colourful as well. It seems that the camera doesn't react to the LED colours as well as your eye. If I press I don't know, number 2, it'll play tune number 2. Lulay, I think that one is, isn't it? And then 3. That's Jingle Bells. Anyway, I made another video earlier. You'll find that if you look back through my videos, you'll find one showing how to also play it as a keyboard. Just have a look at this. Just have a look at this connection diagram. So you can see there's the schematic of the chip, which I think I showed before, showing to connect VCC, ground, transmit and receive. And in terms of the octagonal star board, that's how I've connected it. The star point 1 square pin, which I used the white and orange wire, goes to the programmer TXD pin. The star point 2 square pin, I use white and blue, programmer RXD. The battery holder is the programmer plus 5 volts, and the buzzer pin that's nearest to R2 is the ground, and that's the one that you disconnect when stcgal asks you to cycle the power. I think that's covered everything. So links to the C source code and the compiled IHX file are in the description to the video. Any questions, put them in the comments and I'll try and answer them. Don't forget to like and subscribe if you want to, and thanks for watching.